Good morning to everyone. We are discussing a topic on analytic function. Define a complex function or an analytic function. First, we explain the complex numbers. The numbers of the form z equal to x plus iy, where x and y are real numbers and I is the imaginary units. This is a complex number. Then move to complex functions. That is f of z equal to u of xy plus I into v of xy is the main format of analytic function or maybe function. So an analytic function f of z is said to be an analytic in a domain D if f of z is defined and differentiable at all points of D. The function f of z is said to be analytic at a point z equal to z0 in D if f of z is analytic in a neighborhood of z0. As a formal definition, state that f of z is analytic in a region if its derivative exists at every point in that region and the derivative itself is continuous. Okay. Hence, the analytic function f of z at z0 means that f of z has a derivative at every point in some neighborhood of z0. Include the z0 itself. Since in the definition, z0 is a point of all itself neighborhood. The concept is very clear to analytic function, that is all the points have the continuous differentiable functions. So the analytic function is also known as holomorphic functions. Analytic functions are very much examples are near maybe നമ്മുടെ polynomials and the rational functions. Main functions are the clear functions are the non-negative integers powers 1 z z square are the polynomial functions, and the rational functions, that g of z by h of z form, are the main important rational functions and the importance of analytic functions. The main criteria for the analytic function properties is the Cauchy-Riemann equation. That is, Cauchy-Riemann equation are the most important equation in this chapter. That is, w equal to f of z equal to u of xy plus I into v of xy be an analytic function. Then we can define f is an analytic in a domain D if and only if the Cauchy-Riemann equation satisfied. That is, the Cauchy-Riemann equation is ux equal to vy and uy equal to minus vx, where ux and vy are the partial derivatives. That is, ux equal to dou u by dou x, first partial derivative of u with respect to x, and uy be the first partial derivative of u with respect to y, and vy be the first partial derivative of v with respect to y, and vx be the first partial derivative of v with respect to x. For an example, this Cauchy-Riemann equation for a function f of z equal to z square equal to x square minus y square plus 2ixy. That is, z square means x plus iy all square. That is x square plus 2 into I into xy plus iy all square. That is x square minus y square plus 2xi. So which is analytic? We can calculate u as a x square minus y square. That is the real part. And v is the 2xy. That is the imaginary part. Then we can find ux, vy, uy, ux. Okay. Then ux be the u means the x square minus y square. Then ux may the 2x. And uy be the minus 2y. Then v is the 2xy. So vx be the 2y. And vy be the 2x. So ux equal to vy equal to 2x. So the first condition is hold, and uy equal to minus vx, that is equal to minus 2y, that is also hold. So the formal definitions of Cauchy-Riemann equation is that f of x equal to u of xy plus I into v of xy be defined and continuous in some neighborhood of a point z equal to x plus iy, and differentiable at z itself. Then at that point, the first order partial derivatives of u and v exists and satisfies the Cauchy-Riemann equation, that is ux equal to vy and uy equal to minus vx. Hence, if f of z is analytic in a domain D, those partial derivative exist and satisfies this condition, that is Cauchy-Riemann equation, ux equal to vy and uy equal to minus vx at the all points in the D. Okay, thank you for the class, and that is analytic function. Stop here.